So here we have the circle in section 2 of chapter 10. We are talking about tangent lines. Yes, I said tangent lines. However, that is not the same tangent as the trig. Okay, different meaning. Okay, now we're actually putting a meaning to the word tangent, not the trig function. Okay, so with these, I want you to go ahead and draw yourself a radius. And then let's label the point on the edge of the circle. Let's just label that R for now. Okay, so that's our point R. Tangent lines, go ahead and draw a line on the outside of the circle with it only touching that point on the edge. Okay. This line right here, that is our tangent line. Now I'm going to give you a definition for that. So, tangent line. What a tangent line is, it is a line on the outside of a circle that touches the circle at exactly one point. And then underline the words exactly one point. Some other things to label here. This point right here, where that tangent line meets, that point R, that is called the point of tangency. Okay, label that. This is the point of tangency. So if you ever see that, that is just the point where the tangent line meets the circle. Okay, so our point of tangency in this case would be point R. Okay. One more thing to add about tangent lines, and probably the most important. What makes a tangent line is that tangent lines create a right angle at the point of tangency. And then go ahead and underline right angle. What do we know about right angles? 90. They're 90 degrees. Yep. So this tangent line here forms a 90-degree angle. And again, that would go for both sides. That right there is all you need to know about tangent lines. Okay? Tangent lines touch exactly one point on the edge of the circle, and they create that 90-degree angle at that point of tangency. Okay? I'm going to ask you this. If I draw a line that looks like this, is that a tangent line? Why not? It touches two different points, right? And it goes through the inside of the circle. I'm going to ask you this. Is this a tangent line?
Yeah, sure. Depends if there's a radius. I mean, it's trying to touch a point.
Okay, it's touching a point, but what else do we need to know if it's a tangent line or not?
It's at a right angle.
I have to tell or clarify with you that it is a right angle. So right now, is this a tangent line? No. If I add a right angle here, now is that a tangent line? Yes. Okay. Off to the side of example 2. Go ahead and draw this picture. Make sure you have all the labelings correct. Go ahead and draw it off to the side of example 2 for me. So, on this example, looking at the picture, which one would you say could be a tangent line?
J.
The point is J, but the whole line would be KJ. Do we know for sure if it's a tangent line? No. The question I want us to ask, and I want you to label it this way, ask yourself, is KJ a tangent line? That's the question we're trying to ask here. Is KJ a tangent line? Again, in order for it to be a tangent line, you guys said we're missing the right angle. So, question is, we want to figure out, is this a right angle or not? How do you think we figure that out? It is Pythagorean theorem. Yep, so Pythagorean theorem is that a squared plus b squared equals c squared. We're going to plug values into there to see if it's true. Okay, so what value can I plug in for a? Assuming you talked about these two. 2 legs, right? 9 squared plus 6 squared. What's my hypotenuse?
10 squared.
The whole thing is 10. 10 squared. So we just evaluate. 9 squared is 81. 6 squared, 36. 10 squared, 100. If I add those two together, I get 117 equals 100. Is that a true statement there? No. So does this make a 90-degree angle? No. So that means no, KJ is not tangent. If it came out to be 100 equals 100, what would that tell us? It would be yes, it is a tangent line. Okay. I'm going to warn you, this is going to come back a lot, especially with tangent lines. But that should make you feel comfortable because we know how to use them. We know what to do with it. Okay. I want to take a look at this example real quick. You do not have to draw this one. It wants us to find the measure of x here. Now, in geometry, you always want to go back to what you know. Okay? Right now, I see this shape in here. Do you see that? What kind of shape is that? How many sides? Quadrilateral has 4 sides. Okay? What do I know about the angles of a quadrilateral? Those ones add up to 360. So, and in the directions, right now, does this tell me anything about tangent lines? No. Why? There's no right angle here. However, make sure we read directions. It tells us that they are tangent. Okay, so if it tells us they're tangent, I know these are 90 degrees here. So, knowing that information, can I find the value of x? Yes. I'm going to add up all those angles. 90 plus 135 plus 90 plus x. We know all of those should add up to 360. Okay. What's these three added together? 315 plus x equals 360. Well, what's my last step there? Yep. Subtract 315. So you get x equals 45. So that angle there is 45. So in geometry, you always want to look for things that you're familiar with to help you solve new problems. Okay? All right. Now I want to look at these together. So looking at part A, it's wanting us to know or to figure out, is MP a tangent line? So MP is here. Remember, yes, it looks like it's touching one point of the circle, but what are we really trying to figure out? If it's a right angle or not. How do I figure out if it's a right angle if I know 2 of the angles? Add them up and subtract from 180. So your part A, you take 58 plus 33, which is 91. What do I do with that 91? Take 180 minus 91, which is 89. So if this angle right here is 89, is that a tangent line? No. So your answer to part A is no. And whenever it says explain, this is explaining enough. Okay? Letter B says if LK is tangent to circle N at L, what is KN? So it's telling us that LK is tangent. So what does that mean? It creates that 90-degree angle. So this time it gives us sides. So what are we going to use to help us find x? It is going to be Pythagorean theorem. Yep. So we're going to I'm going to erase this. We are going to follow that a squared plus b squared equals c squared. Now remember, as we're adding more things to the circles, always think about what you know how to do. Okay? In this triangle here, what is something I can fill in? Oh, this one? I'm going to say no because it is only if we have 2 straight lines. So like this is not a straight line. This is not a straight line. Yep. But good idea to see that. Do I know the length of this side? Why is it 9? All radius are the same. So even, we don't need this side, but what's this side? 9, and this side is also 9. Yep. So we know this side is 9. So do we know everything about at least every single side of this triangle? Yes. So let's plug it into the Pythagorean theorem. What can I plug in for A? 9 squared from here. What's B? What's the other leg? It's that whole x plus 5 squared. equals our C. It's going to be this whole length. So let's combine those right away. What's x minus 1 plus 9? It's x plus 8. Yep. So that's what we put in for our C value there. Now, this looks very messy, but I'm going to tell you it works out very nice at the end. Okay? This just turned into an algebra problem. So it's always a good review to do some algebra here. What's 9 squared? 81. What does this mean? What did you say? We are going to have to FOIL. Remember, this does not just mean we distribute the 2. This means multiply by itself. Okay, so this is going to turn, I'm going to come off to the side. This is going to turn into x plus 5 times x plus 5. Okay, so how we do that, remember we FOIL. So we take x times x, which is, that gets you x squared. And then x times 5, 5x. Come down here, 5 times x. 5x, and then finally 5 times 5, 25. I know it looks messy. I promise you it turns out nice in the end. Okay, so what do you think we do with x plus 8? The same exact thing. Yep, x plus 8 times itself, x plus 8. So again, x times x is x squared. X times 8, 8x, 8 times x. 8x, 8 times 8, 64. Now, I'm just going to clean up both sides. I'm going to combine like terms on both sides. So on this side, I should have x squared plus 10x plus 106. And then on the right side, I should have x squared plus 16x plus 64. Okay? Now, our whole goal is we want to find x, right? If we subtract either one of these to either side, what's going to happen? What's going to happen if I do this? They're going to end up canceling out. That's what I meant by it turns out nice. Those x squareds are gone right away. Okay? Now, this just turned into a normal algebra problem. What can I do first? Okay, I could subtract 16x. So I get negative 6x plus 106 equals 64. What can I do next? Subtract 106. This gives me negative 6x equals negative 42. Last step here would be to divide by negative 6. So we end up getting x equals 7. I know that was a long example. It's always good to review algebra. Not every single problem is going to be like that. Okay? So it tells us x equals 7, but what did your part B really want you to figure out? What did it want you to figure out here? It wanted you to know what the length of Kn is, okay? So Kn is this line right here. So what do we do if we know what x is? Plug it in. If I plug it into here, 7 minus 1, 6. So then to find this whole side, yep, I take 6 plus 9, which gives us 15. Yep. All right, so here I'm going to give you one more definition that you can write off to the side of example 3. Okay? I'm going to take us back a little bit to chapter 4. Okay? First of all, are these tangent lines? Why? Forms the 90-degree angle and it touches at one point. So we know that these two are tangent lines. Okay? Why else do we know that these are the same? They have the congruent markings, but if they didn't have those, they're radius, right? So we know all radius are the same. Cool. Do you see how we have two right triangles here? Okay? Think back to how we knew if triangles were congruent or not. Huh? They share the side. Okay? I agree with that. This shared side is the same. Can I assume that these two sides are the same? Right now I can't because they're not connected. Okay? But if I have a right triangle, what one do we automatically go check for? Out of side, side angle, side. What'd you say? Hypotenuse, leg. Yep. No, these aren't coming back. Okay, I'm just doing this to explain this. Okay? So these two triangles are congruent by hypotenuse, leg. So what does that tell us about these two lines then, if we know the triangles are congruent? they're also the same. Okay, so here's the definition I want you to write for this. Okay, if two tangent lines meet at the same point outside the circle, then they are congruent. Again, what does congruent mean? The same measure. Yep. So if two tangent lines meet at the same point outside the circle, then they are congruent. What's that same point that they meet at? Z. Yep. Those two tangent lines meet at point Z, so we can assume that they are congruent to each other. Okay, on number 3, it tells us that TX is 12. What else do I know is 12? The other side, right? TY. All radius are the same. Remember that fact there. And then it tells us that TZ, this middle line, is 20. It wants us to find XZ and YZ. First of all, what do I know about those two? They're the same. Again, why are they the same? Meet at the same point. Yep, and they're both tangent lines. Okay. How do I find that missing side? Pythagorean theorem. Yep. So we have a squared plus b squared equals c squared. Remember, c is always supposed to be your hypotenuse. Okay, what's our hypotenuse value? 20. And then what else we have is 12 squared plus x squared. So to solve this, what's 12 squared? 144 plus x squared equals 400. From here, subtract 144. So we have x squared equals 256. Yep. And then last step always, square root x equals 16. What did that just give us? It gave us both sides, right? Both of these sides are 16. Good. All right, on example 4, all it tells you to do is find the perimeter of ABCD. So it wants to know the perimeter of that quadrilateral on the outside. Okay, what is that quadrilateral made up of? How do I know they're tangent lines? Because of the right angles, right? Sometimes, like in your homework, they won't always give you the right angle in the picture. Okay, sometimes they'll tell you in the directions that they are tangent lines. Okay, so just make sure you're reading directions for those. So I'm just going to focus on this tangent line right here. If this is 7, what do I know about this one? It's also 7 because they meet at that same point on the outside. Okay, so if this side is 2, what's this side? Also 2. What's this? 3. This side is 6. So to find perimeter, again, what's perimeter mean? Adding up all of the sides together. So add up all of those sides and you get what? Should get 36.